Hello, myself Amol Diliprawkare, Assistant Professor, Department of Chemistry, Swami Vivekananda Senior College, Manta. I am going to teach you today's topic: conventional representation of an electrochemical cell. For that, we have to know what is meant by the electrolytic cell and electrochemical cell. Here, in case of electrolytic cell, which is in a non-spontaneous chemical reaction, that means in electrolytic cell there is a non-spontaneous chemical reaction which are produced by the passage of electric current known as the electrolytic cell. While in case of electrolytic cell, chemical reactions are produced by the passaging of electricity. Now see, this is the figure of electrolytic cell where the water consists of electrolyte, where this electrolyte dissolve into the ions cation and anion, which forms the passage of electricity. Now, another cell known as electrochemical cell, and these electrochemicals are also called as the galvanic cell or voltaic cell. A cell in which the electricity can be generated by spontaneous redox reaction and is known as the electrochemical cell. And this electrochemical cell can be constructed by combination of two half cell which is connected internally by the salt bridge and externally by the metal conductor. This is the figure of electrochemical cell. Now see, in this figure the two half cells are connected by the salt bridge and the two metals are conducted externally, where the two metal conductors, where the one of the reaction occurs oxidation, another reaction occurs reduction. That means both these occurs called as the redox reaction. A reaction where oxidation reduction takes place is known as the redox reaction. Now we have to differentiate what is the difference between electrolytic and electrochemical cell. In case of electric cell, as we know, this electrolytic cell will convert the electrical energy into the chemical energy, while this use this reactions occurs non-spontaneous and it consumes the electric energy. That is an example, extraction of metals on electroplating. While in electrochemical cell, it converts the chemical energy into electrical energy and it used to produce the electricity from the spontaneous chemical reaction, and it produces the electrical energy. The electrochemicals are dry cells, lead accumulated, etc. Now, while writing the electrochemical cells on the paper or on the board, we have to represent that electrochemical cell, and that there are some rules while representing the electrochemical cell. Now, in the cell diagram, which is abbreviated representation of electrochemical cell, and that cell consists of two half cells which are in contact with the metal ion solution. One electron involves the oxidation at anode, while other involves reduction at cathode. In 1953, the IUPAC recommended following convention for writing the cell diagram. Rule first: oxidation electrode, that is anode, always forms a left part, and reduction electrode cathode forms a right part of the cell. Rule number 2: half cell is represented by interposing a vertical line or semicolon between the metal and the electrolyte. Now see, this is the example where the two half electrodes, anode half cells and cathode half cells. Anode half cells as written to the left side while cathode on the right side, and both the electrodes are separated by vertical lines. Rule number 3: in case of the gas electrode, gas is adsorbed on inert metal like platinum. The symbol of inert metal is often enclosed in a bracket. The example, the hydrogen electrode may be represented as. Now see, whenever there is a gas electrode and that gas is adsorbed on the inert metal like platinum, that we have to mention by this way. Rule number 4: in the complete cell diagram, double vertical line is interposed between the two half cell if a salt bridge is used in connecting two electrodes of the cell, where is dotted line is used for porous partition is used. Now see, this is the example where while writing the complete cell diagram, these double vertical are inserted between the two metal electrodes, which indicating that half salt bridge is used in connecting the two electrons. This double vertical indicates that the two half cells are connected by a salt bridge, which is indicating the double vertical line. Rule number 5. The EMF for cell as well as or half cell depends on the concentration of electrolyte and temperature. The concentration of electrolyte is mentioned in bracket in front of the electrolyte, and the value of EMF is written on the right of the cell diagram. Now see the below example, the concentration of the electrolytes are written in front of the that electrolyte. Now here in case of zinc sulfate in concentration 1 molar, and double vertical which is indicated as a salt bridge, and copper sulfate 1 molar, and the EMF of a cell is written on the right side of the cell. Rule number 6. The EMF of cell can be calculated from the half cell potential of two half cells by using the formula E cell equals to ER minus EL, which is E cathode minus E anode. If the value is positive, conventionally electric current flows from anode to the cathode through the external circuit, and the negative sign indicates that the cell is not feasible in the given direction, and the reaction will take place in the reverse direction. So this is the conventional representation of electrochemical cell. As we are suffering from the COVID-19, so it's my humble request to all of you, stay home, stay happy, stay healthy. Thank you.